Hello everyone, this is Ayush R from IIT MADRAS, and today we are with our new topic, that is escape velocity of Earth. Escape velocity of Earth. This is the center of Earth. This is the center of Earth, and the radius of Earth be R. And the radius of Earth be R. An object is thrown vertically upward from here. It again comes here. It again comes here. Again it is thrown from the next point. It again comes on the Earth's surface. But a critical point when the object escapes, the Earth's gravitational pull, so that velocity is known as escape velocity of Earth. So how do we calculate the value of escape velocity? So some potential energy of that object here. So that potential energy be U, and we are taking that magnitude of potential energy. So Gm small m by r is equal to the potential energy of that object on Earth's surface. When it is thrown, the potential energy becomes the kinetic energy. The potential energy becomes the kinetic energy when the object is thrown. So the potential energy be U, the magnitude of U. Potential energy be the magnitude of U. An object is thrown vertically upward so that it opposes the gravitational pull, and the gravitational pull is not sufficient to pull it back again. So that object escapes the gravitational pull of Earth and escapes the Earth's gravitation. So that velocity, critical velocity, is known as escape velocity of Earth, represented by VE. So when the object is in hands, it was taking the value as potential energy as mod of U is equal to Gmm by R, where m is the mass of Earth, small m be the mass of object, R be the radius of Earth, capital M be the mass of Earth, small m be the mass of object, and R be the radius of Earth. Again, when the object is thrown, it attains some kinetic energy. The value of that kinetic energy is given by Ke is equal to half mv square, taking escape velocity, so Ve square, taking it as second equation. On equating these two energies, the potential energy must be equal to the kinetic energy. When an object is thrown vertically upward, the potential energy transforms into the kinetic energy. So these two equations must be equalized. So equation first will be equal to equation number second. So take a snapshot of it. Now we are taking the comparison of these two equations. So comparing equation first, on comparing equation number first with equation number second, on equalizing the both equation, so U must be equal to, mod of U must be equal to the kinetic energy of the object. The kinetic energy the object attains, some kinetic energy the object attains when it is thrown vertically upward, so that it can oppose the Earth's gravitational pull. So the value of mod of U is equal to Gmm by R, and the value of kinetic energy is equal to half mv square, taking escape velocity as half mv square. On equating, m to m will be cancelled out, and this 2 will be coming to this side. So 2Gm by R is equal to Ve square. 2Gm by R is equal to Ve square. Now roots are of Gm by R multiplied by 2 multiplied by root 2 is equal to Ve, escape velocity's expression. So this is the value of Ve. Take a snapshot of it. Now since we know at Earth's surface G is equal to Gm by R square. G is equal to Gm by R square. So it is also equal to Gm by R multiplied by R times R. Taking one R to this side, we get Gr is equal to Gm by R. Now on substituting this value in this equation, we will get root 2 multiplied by roots over of Gr is equal to Ve. Okay, so V is nothing but the escape velocity of Earth, and it is equal to roots over of 2Gr. Ve is equal to roots over of 2Gr. That's the next expression for this. The first expression was from equation number 3rd. We got roots over of 2Gm by R was the expression. These both equations are very helpful. On calculating the escape velocity of Earth. So what is the escape velocity of Earth? We can find. Simply we can put radius of Earth is equal to 6.4 into 10 to the power 6 meters. We can put G is equal to 9.8 meter per second square. So V is equal to, in terms of Earth's escape velocity is equal to, so Earth's escape velocity is equal to roots over of 2 multiplied by 9.8 into 6.4 to 10 to the power 6 into 10 to the power 6. So on simplifying this, we will get 11.312 kilometer per second. 11.312 kilometer per second. The escape velocity of Earth is 11.312 kilometer per second. How big this value is? 11.312 is approximately equal to 11 and half kilometers in a particular second. Say this is a very big value, and 11.5 kilometers per second, an object is traveling with 11.5 kilometers per second, so it will be opposing the gravitational pull of Earth, and it will be attaining its escape velocity, which will be represented by Ve. So that's all for today. Meet you in the next video lecture. Thank you.